Notes 5C. Solving systems of equations. Objective. I can solve systems of linear equations with and without technology. Essential question. How do I solve a system? Vocabulary. System. A collection of two or more relations with the same set of unknowns. Relation. Two or more expressions that are linked together by signs such as less than, lesser equal to, greater than or equal to, greater than. Substitution. Plugging in an expression for a specified variable. Elimination. Getting rid of one variable and solving for the other. Coefficient. Quantity of a variable. Using the Nspire to find solutions. LidSolve instructions. You press Calculate, Menu, 3, 2. Note, this will not work if the system has infinite solutions. Number 1, y equals 8 and negative 7x plus 2y equals negative 19. To find this in the calculator, we first go to Calculate. To get to LidSolve, we press Menu, 3 Algebra, 2 Solve System of Linear Equations. There are two equations here, so you just press Enter or OK. In the first box, we type in our first equation, exactly how we see it, equal signs and all. Go down, type the second equation in the second box. The next step, make sure that you've typed everything in exactly how it should be, exactly how it looks here. Once you've double checked, go ahead and press Enter. That's your solution. X equals 5, y equals 8. So our intersection is 5, 8. That's our solution. Number 6, negative 12x minus 7y equals negative 29, and 12x plus y equals 35. So to find in the calculator, we do the same thing. Press Menu, 3, 2. There's two equations, press OK. Type in the first equation into the first box, and type the second equation into the second box. Double check to make sure everything looks exactly like the system on the page, and then press Enter. Your solution is 3, negative 1. So your intersection is 3, negative 1. So that's how you would find it in the calculator. Now to find it by hand, this case, substitution would be easiest. And for this one, elimination would be easiest. We'll talk about those in just a few minutes. Evaluate review. F of x equals 5x minus 3. So f of 0 equals 5 parentheses 0 minus 3. Wherever you see an x, you replace it with parentheses 0. And that's exactly what you plug into the calculator. You type in 5 parentheses 0, close parentheses, minus 3, and then you press Enter. Your answer is negative 3. Do the same thing for the next one. 5 parentheses 4 minus 3. That's 20 minus 3, 17. F of negative 2, we have 5 parentheses negative 2, minus 3. Negative 10 minus 3, that's negative 13. The last one has an expression. You still replace it in the same place though. 5 parentheses y plus 1 minus 3. We can't put this in the calculator, So let's just simplify what we have. Distribute the 5, 5y plus 5 minus 3. 5 minus 3 is 2. So your simplified expression is 5y plus 2. Solving systems with substitution. There's 3 cases. You evaluate f of g of x. Basically, it's like these right here, except for you have 2 equations instead of 1. The other case is set the equations equal to each other. And the last case is to solve for y or x, and then you evaluate. Let's look at case 1. Solving systems with substitution, evaluate f of g of x. We'll say that the first equation is g, and the second equation is f. So, we know that y equals 6, so wherever we see a y in this second equation, we're going to substitute 6. So, it would look kind of like this. 5x plus 4 parentheses 6 equals negative 6. So we have 5x plus 24 equals negative 6. Subtract 24 from each expression. 5x equals negative 30. Divide each term by 5 to get the x isolated by itself. X equals negative 6. And we already know that y equals 6. So we write y equals 6 right here. X equals negative 6. Let's go back through and write down all the verbal steps. So your verbal steps, step 1, substitute 6 for each y in the second equation, equation 2. Step 2, subtract 24 from each expression. Step 3, divide 5 each term. X equals negative 6, y equals 6. Solving systems with substitution. Evaluate f of g of x. We'll say that the first equation is the f and the second equation is the g. So, wherever we see a y in the first equation, we're going to substitute negative 4x instead. 6x plus 6 parentheses negative 4x equals 0. From here we want to distribute that 6. 6x minus 24x equals 0. Combine like terms. Negative 18x equals 0. Divide each term by negative 18 to get x by itself. X equals 0. Let's summarize the steps that we've done so far. Step 1, substitute negative 4x for each y in equation 1. Step 2, combine like terms. And step 3, divide negative 18 by each term. From here, we want to plug in 0 for every x in equation 2. So y equals negative 4 times 0. Negative 4 times 0 is just 0, so y also equals 0. So your intersection, your solution to the system is 0, 0, the origin. because both x equals 0 and y equals 0. Solving systems with substitution. Set equal to each other. Y equals x minus 5 and y equals negative 4x plus 10. We can set these two expressions equal to each other to solve for x first. So if x minus 5 equals negative 4x plus 10. The reason why we could do this is because both of these equations are equal to y. That's why we can set them equal to each other. So from here, let's add 5 to each expression. X equals negative 4x plus 15. You want to get all the x's on one side, so let's add 4x to each expression. 1x plus 4x is 5x. Negative 4x plus 4x is 0x. So if 5x equals 15, divide each term by 5 to get the x by itself. 1x equals 3. And then the next step, we want to substitute 3 for each x in equation 1. We could also do equation 2, but equation 1 looks easier. So y equals 3 minus 5. 3 minus 5 is negative 2, so y equals negative 2. Our solutions are x equals 3 and y equals negative 2. Solving systems with elimination. There's 3 cases. Add the equations, also called rows. Subtract the equations, multiply the second row by negative 1, and multiply each equation to get the least common multiple of x or y's coefficients to get them to eliminate. Solving systems with elimination. Add the equations, the rows. We have negative 5x plus 2y equals negative 4, and 5x minus 11y equals negative 23. Examining these two equations, if we add them together, we would eliminate x. That's what we want. So we'll go ahead and write that out. So we're going to combine the two equations to get a third new equation. 5x minus 5x's, no x's, they're eliminated. 2 minus 11, negative 9, negative 9y equals negative 27. From here, we could divide each term by negative 9 to get the y by itself. So 1y equals 3. After we find that y equals 3, we could plug it back into our equation to find x. So we have negative 5x plus 2 times 3 equals negative 4. Distribute, we have negative 5x plus 6 equals negative 4. Subtract 6 from each expression. Negative 5x equals negative 10. Divide each term by negative 5. X equals 2. So our solutions are y equals 3 and x equals 2. And that's all. Remember, you can check your answers using the calculator, using either the graphing function or LinSolve.